All right, let's take a look at example 3, reasoning about similar triangles to determine side lengths. Show that the two triangles in this diagram are similar, then determine the values of x and y. So let's just take a quick look at this triangle. I see two triangles. I see a big one. So I've got ABD. I also see a smaller one, ECD. I also noticed that there are some parallel lines happening. And I also note that there's a shared angle. So I can see that in this big triangle, ABD, there's this angle D at the top. And I can also see that in the smaller triangle, D is also one of those angles. And then in terms of our unknowns, we're looking at x and y. So first of all, let's kind of put these observation downs in a little bit more of mathematical notation. So in the last video, I talked about different ways of naming angles. And if I want to look at angle A here, right, I can actually either just call it angle A, or I could also describe what's around it. So here, B, A, D. So that's another option. I can write B, A, D. And I can say, hey, you know what? That's got to be the same angle as CED. Right? So CED. And how I know that is when I have parallel lines. So I'm just going to draw a quick diagram here. When I have parallel lines and I have a line that kind of traverses through it, I can say that this angle and this angle are actually equal to each other. So I can say that angle BAD is also equal to angle CED. Could I make another conjecture? Yes. I could say the bottom left angle, so ABD, okay, ABD would be equal to which one? ECD. So ECD. And by describing that these two angles are the same, I can actually know and make a conclusion that the triangle ABD is actually similar to ECD, the smaller one at the top. So a reminder from the first video that this little squiggle kind of looks like a sideways S. There's no real proper way to write it. Basically means similar to, okay? Now, another method in which I could talk about similarities is I could look at proportions. Oops. Proportions. Okay. So I could look at BD, right? That one there. BD. And I could compare it to the smaller left side of that triangle, CD, right? So I could say, let's look at the relationship of those two. And then I could look at the proportion of, say, AB, that'll be here, And is that proportional to CE? CE. Okay. And as I've said before, it really doesn't matter what order you use. If you want to write EC, that's not a problem. So I'm going to do a little bit of calculation. I can say that BD, right there, BD, that's 8 plus 6. So that's actually 14 units long. And then CD is 6 units long. And I could use that to find X. That's our unknown. We don't know what the X is. And knowing that these two triangles are similar, right? Like we can use these proportions, these ratios, fractions to find what X is. And we know that that X is going to be proportional to CE, which is right over here. That's 6 centimeters. Okay. So we basically do a little bit of algebra. One option is we could actually just multiply each side by 6. And when we do that, we basically cancel these, right? So top and bottom fraction are going to be the same, and top and bottom are going to be the same. So essentially what we end up concluding is X is actually just 14.0 units long. Centimeters. Centimeters. Now, what about y? Let's solve for y. So what sides could we use? If you want, you can actually hit pause on the video and see if you can come up with this proportion. So what we're going to do is we're going to look at AD here. Okay. So AD. And then we're going to look at ED, which is that little segment there. And then I'm going to look at, again, we have to keep consistent to the triangle. So I used the large triangle in the top value and then the smaller one on the bottom. And if you switch those up, that's totally fine too, but as long as you stay consistent. So let's use BD, that's this segment there. And then we can use CD, which is this smaller segment. And let's plug in some numbers. So with AD, I don't actually know what AD is because this, I just have 3.6 and Y, so I actually have to add those together. And that's okay. But ED, I do know what that is. It's actually just 3.6. For BD, that's going to be 6 plus 8 again. That's 14. And then for CD, that's going to be 6. So what I can actually do is, how am I going to get rid of this? So why don't we multiply both sides by 3.6? Okay. And so on this side, that's going to cancel each other. And then we're going to get 3.6 plus y equals 3.6 times 14 over 6. And if I calculate the left side there, I'm going to get 8.4 and y plus 3.6. So when I have that left, I'm going to isolate the y and do 8.4 minus 3.6. And then in the end, I'm going to get 4.8 units. So 4.8 here and 14. And one thing that's a good thing to do is just kind of like take a quick check at all the numbers, right? Like, is 4.8 kind of making sense? If you get 72, that's obviously going to be a little bit off or way off, but 4.8 seems pretty reasonable. And if we take a look at 14, is that generally reasonable to this image? Yes, I'd say so. So our conclusion is that X is 14 centimeters and Y is 4.8 centimeters.